So today we're moving into a new module, Module 7, Section 1. We're going to be looking at graphing exponential functions. So a little bit of vocabulary. An exponential function is something that has the variable x in the power. So 2 to the x, 3 to the x plus 2 minus 1, 4 times 2 to the 3x minus 1 plus 6, and so on. A growth function is whenever we have a number to a certain power that's greater than 1. So if the number there, which is called the base, if the base is greater than 1, and that would be the absolute value of the base is greater than 1, then it's growth, and it's decay if the absolute value of the base is less than 1. So somewhere between 1 and 0. So it has to be somewhere between 1 and 0, which is really what that represents. And then if you recall, an asymptote is a line that the graph approaches but never crosses. So if we have a graph and we have an equation that looks something like this, it'll get closer and closer to the x-axis, but it'll never cross. But it does keep going down, just never crosses. So some things to explore with in this particular case. I'm going to pause it for a minute. Okay, so now what we want to do is we want to explore some of these functions and kind of see what happens. So notice that we have y equals 2 to the x, which is my parent function. And if you take a look at that on Desmos, you will see on Desmos how that function actually looks. So going in and logging into the graphing calculator, and we do y equals 2 up arrow x, and you can see how the function increases. So it's getting really close to 0 as it goes to negative infinity, and then it shoots up towards infinity as x goes to positive infinity. So as x gets larger and larger, y gets larger and larger significantly. So it's exponential. So that means that it's going to go up a little faster than just a straight line. And so that's what that would look like. So then what we take a look at is, well, what happens if we add 4 to it? So if we add 4 to it, that should give you an idea of when we've done functions before. If we add 4, it just means that this axis where y equals 0 basically moves up to where y equals 4. So remember that this causes every point to go up for 4 positions. So that's what it does when we add 4. When we subtract 3, you'll notice that it changes and goes in the other direction, so it'll go down 3. So notice that this is the line y equals 3, so it went down and it gets closer and closer to that as x goes to negative infinity. Where else do we go? So now we put the 3 up with the x. If you recall, when it's ever with the x, so I have to put parentheses around this, so x minus 3. You'll notice when we do an x minus 3, this point, which was actually located over here, so we were actually moving it that way. Remember, I'm sorry, when it was located over this way, minus 3, that moved 3 positions over. And actually, the points that we can see here is this one right here. So this is where it crosses 1, and if I didn't show you that at the beginning, but I'll show you that in a minute. But notice that this moved over 3 this way. So if I kind of back it up and I just put the x there, notice here it crosses at 0, 1. When I go inside and I do a minus 3, it actually moves it 3 to the right. Remember, this is always moving the opposite direction. Of course, if I put a plus in there, you notice that the 1 point, which was located right here, moved over this way 3. So we can see that. And then we have 3 times. So if I multiply a number on the outside, so let's go ahead and get rid of that part right there. And let's do 3 times that. So notice that instead of it being at 1, it multiplied all the numbers by 3. So instead of being at 0, 1, it's at 0, 3 because it multiplied the numbers by 3. And of course, if we go something like this, 1/3, it's going to be cut in down to 1/3 from 1. So we can see at that point it's 0.333 in that particular example. So we can see how kind of it's shifting around and doing some things. Now notice if I put a 1/3 or a number in with the x, which is a little different. So I'm going to take this out. And now I'm going to put a number up here. So if I put a 3 here, you notice that the 1, 0 point, which kind of shifted around, but notice that we have the 3 there. It's actually moving it up to 0, 1. So that's staying the same. But you notice that when the 3 goes with the x, how much faster it's actually shooting up. What it's really doing is it's actually squeezing the number. So it's actually causing the values this way to squeeze in by 1/3. You'll notice that 1/3 is going to stretch it out a little bit more. If I do 1/3, you notice it stretches it out a little bit more. Okay, so it takes its time to kind of go up in that particular case. So we can kind of see different ways of doing it, and we can kind of understand what's happening. If I do 3, notice that the 3 just causes it to kind of go up 3 times faster, but that 1/3 is making a little bit of a difference. You want to kind of play around with those and see what happens. And then the very last thing that we're going to throw at you is what happens if I have a negative here. Notice that it shifts around the y-axis when the negative's with the x, and it shifts around the x-axis when the negative is around the y. And the y is really this particular part of the function. So you can go and kind of experiment around and kind of see how it shifts around as it goes through there. So that takes care of the first video. You can see what happens here. This one goes up 6 to the right 1, inverts over the x-axis, and goes down 4 times faster. So we can see all these different things kind of play into effect. So -4. So I'm actually going to type this in. So y equals -4 times 2 to the x minus 1 power plus 6. So you can see what happens here. So notice plus 6 causes it to go up 6. The minus sign in front causes it to invert down instead of going up. The 4 means it's going to go down 4 times faster as it does that, but it had to shift 1 to the right. So it moved over here. Notice here 1, 2, 3, 4 instead of 1. So it went down 4 times faster. So all these different things make sense, should make sense as to how the function is going to look. And that's it.